that was. For what though? For what? I hope so. The only thing is we haven't done physics, so like you would have covered the content with me in that sense. So try and put some extra focus on physics because we've covered chemistry and we're covering chemistry. We would have done all of biology. Okay. I'll mention in a second. I'll mention in a second. Right, guys, let's make a start. So on, perfect. That's great, Josh. So guys, if you watch the board, I'll show you a reaction. So we've got reactant A and reactant B, and this is a reversible reaction, giving us products C and D. So just very quickly, guys, we said a reaction at equilibrium can be defined with a couple of different definitions. No, not different definitions. Different factors will complete the description of an equilibrium reaction. So what are they, guys? Can anyone remember what they were? So it's sort of blurting what the definitions of equilibrium are. You're thinking of things that can change it. I'm not talking about that. When a reaction is at equilibrium, what does that mean? Right, very good. It means it's dynamic. That's the first one. Very good. So it means it's dynamic, which means what? What does that mean in words, guys? Hold up. What does dynamic mean in words? It means that things are being formed, so products are being formed, as well as reactants being formed. So products formed as reactants formed, and this can change. The change is constant. Okay, so what did we say the second one was? We said it occurs in a closed system. Do you guys remember that? It occurs in a closed system. It can only occur in a closed system. The second thing was, well done, guys. I'm getting this from the chat. The rate of the forward reaction and the rate of the backward reaction are the same. Very good. Fantastic. So rate of forward equals rate of backward. Okay, and the last one was... Ooh, was that the right word though? Was that the right word used? Interesting. I'm going to see if anyone else can spot it just before I put it on. So there was one more thing. Very good. Yeah, well done. Well done, Yasma. Well done, Kivi. Well done. And well done for the rest who put that in. So basically, the concentration of the products and reactants are the what? Yep. Right, the handwriting is atrocious, but hopefully you just remember this from last lesson. Okay, so this is the definition of a reaction that is at equilibrium. You could get asked about it. So let's go back to A, B, C, and D. If you're writing that down, let me know so I can keep it up for a minute. And let's find out where some of these missing people are. Okay, right. Okay. Yes, that's exactly correct, Krish. That was exactly the right thing I was about to say. Oh, thank you, Gianna. Just noticed now. Hope we're all doing well. Yes, sir. Let's go. Where are we? Okay, let's go. Let's go. Let's go. Let's go. Um, why have I gone so? Why did I go? No, 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 no. I was trying to find out where the missing comrades are. Krish, man, I wish I could say yes. Right, but my time is limited, unfortunately. But keep reminding me, it will happen. It will happen. Basically, everyone's nagging me for something at the moment, so. Today at 8:30. Today at 8:30. Right, let's go, guys. So we had A, B, C, and D. So if we increase the concentration... Oh, by the way, what does Le Chatelier's principle set out to do? What does Le Chatelier's principle set out to do? It sets out to something the something. Something act the something. Yes, that's the one. Thank you, Mohammed S. Thank you, Manuel. Thank you, Krish. Thank you, Hassan. Very good. Fantastic. There you go. Exactly, Orbison. Well done. Right. Exactly. Well done, George. So basically what it does, it counteracts the change. Counteracts the change. So, for example, if I increase the concentration of A and B. So if I increase the concentration of A and B, where does the equilibrium shift to? Correct. Nike Orbison did not waste a second of time. We pretty much just started Sequenim. This is a bit of a recap from last lesson, so you haven't missed anything huge just yet. Very good, one on Mania. So basically, the equilibrium will shift to the right. Okay, the equilibrium will shift to the right to bring up the concentrations or the amounts of C and D. Okay, so this will cause. Yes, that's right. That's right. To shift to the right. Okay, so it shifts to the side which it needs to bring up, yeah? Remember, if you increase A and B, does Le Chatelier's principle want to bring down A and B? If you increase A and B, does Le Chatelier's principle want to bring down A and B? I guess by inference, yes, right? By inference. But C and D goes up. So lots of A and B, so it uses it to make up C and D. So A and B goes down, C and D goes up till they're balanced again. Okay? Is that making sense? Yes, exactly. Right. So we're going back. We've got A and B again. C and D. Now, if I decrease C and D, what happens? If I decrease C and D, what happens? Go on, Zia, what do you think? Where does the equilibrium shift to? The equilibrium will shift to the right. Well done. Well done, Ajwa. Well done. Hold on. Well done, yes, well. Fantastic. And well done for those who put it in letters as well. So basically, the equilibrium will shift to the right. Does that make sense? Because it's trying to bring it back up. Okay? If the equilibrium shifts to the right, does it also bring down A and B? It does, right? Because it has to balance it. It's like a seesaw. Okay. Hold on, guys. I just need to load this up. What are the 3 ways that I can influence the rate of reaction? What are the 3 ways that I can influence the rate of reaction? Very good. So I can increase the rate of reaction by increasing temperature, by increasing concentration, by increasing pressure. And well done for the person who said surface area. Well done, Zia. Surface area. Remember, I didn't say equilibrium. I said rate of reaction, right? So just be a bit careful there. How else can I increase the rate of reaction? There you go. That's what I was looking for. I can use a catalyst. Very good. What does the catalyst provide for the reactants? What does the catalyst provide for the reactants? In the examples that you learn. Very good, Hassan. That was exactly the one I wanted. So well done for those who said alternate reaction pathway or lower activation energy. That's true. Those are correct. But it was actually, and well done, Adyan. The word I wanted was it provides a surface for the reactants to bind to so that the reaction can happen at a lower activation energy. Do you guys remember that? It provides a surface. You know what? Sometimes in an exam, just write everything you know about it just to ensure that you don't lose any marks. Especially if they haven't restricted what you can say. Like if it says state only 2, then obviously don't do that. That would be risky. But if it mentions, no restrictions, then just go all out. Right, okay, so we got up to rate of reaction. Okay. Right, the next one I'm about to teach you. The next variable I'm about to teach you is temperature. I'm quite proud of this acronym. Just as proud as I am of the why you outside, bro. That's like the best one I've ever made. But yes, let me show you. Okay. Yo, that was a sick one. That was a good one. If you only have 2, yes. As in, if you have 2 and you write 2, then you get them on. But if you write more, I don't know. I think they just pick it in the order that you wrote down. It's alright, Zion. It's alright. 10-10. Right, okay. Let's go. No worries, Zainab. The effect of temperature on equilibrium. The effect of temperature on equilibrium. Le Chatelier's principle can be used to predict the effect of the changes in the temperature on systems in equilibrium. To make the prediction, it is necessary to know whether it's exothermic or endothermic. Guys, before you look at anything to do with temperature, there's one thing you need to know first. Whether it's exothermic or endothermic. Let me know in the chat if you heard that. How would I know if a reaction in an exam question is exothermic or endothermic? How would I know? Thank you for that, Mania. I just noticed what you typed there. Fantastic. How would I know? Ooh, that is a grade 9 observation. I like that one. Thank you, Arjo, for that one. So I will mention that in a second. Okay, good. Exactly. They may tell you in the question that the reaction releases heat. So thank you for that, Gianna. They might tell you the reaction releases heat to the surroundings. Okay, but there's another one. Okay, so the one they will tell you if it releases heat. Tell you if releases heat. Rose, the overthinking final boss. Releases heat. That's the first one. The second one, they might give you a value. They might say it releases 300 kilojoules. So something like that is exothermic. Okay, well done, Adwan, remembering that. That's awesome. Or if they tell you plus 253 kilojoules, that would be endothermic. Okay, so taking energy from the surroundings, release energy to surroundings. The last one, and this is why I called some of you guys the overthinking final boss, is they just tell you. They'll say student A is conducting an exothermic reaction. Does that make sense? They just tell you straight up, right? So they will tell you. They'll give you a clue. So don't try to do it before you've ascertained whether it's exothermic or endothermic. Let's move on. Yeah, let's continue. What? Yeah, I don't know what you're talking about. Right, let's go. So if the temperature Oh, if they give you a reaction profile, yeah, they might do. Yeah, they might do. But I think the question then will probably be about like bonds and stuff. So they might give you a reaction profile. So you know the one with the hump, the bump like that. Something like that. Okay. So might give you a reaction profile or energy profile is what we call it. Energy profile. Right. Okay. Or reaction profile. Either of the two. Now, if the temperature of the reaction increases, it moves to the endothermic side. Did you guys catch that? If the temperature of the reaction increases, it moves to the endothermic side. Do you see why you have to figure out whether it's endothermic or exothermic first? Do you guys realize why you have to figure that out first? Because how do you know where it's shifting if you don't know what's the endothermic side? Yes, please, Zainab, yes. So you need to figure that out bit. You need to figure that bit out first. Now, do you remember the fact that we learned last lesson? If a reaction is exo in the forward, what does that mean? If a reaction is exo in the forward, what does that mean? Thank you, Krish. Thank you, Manuel. Thank you, Yasma. We need to remember this, yeah? In exam stress, when you're in the middle of an exam and you're stressing, you might forget basic stuff. So I've got to make sure you know it well. Well done, Zia. So if a reaction is exo in the forward, Annie, man, let me know if you're there. I feel like you're stuck in a vortex where you can't respond. Let me know if you're there. So if a reaction is exo, oh, that was instant. Let's go. If a reaction is exo in the forward, therefore it's endo in the what? In the backward. So be very careful that you have figured that bit out. So if it increases, it's endothermic. Therefore, if it decreases, it's exothermic. The best way to remember it is in N. Okay, they both sound the same. If you know this one, the other one's obvious. It's just the opposite. Let me know if you caught that. So for this slide, really, what you need to get down is this. Let me know once that's down. If the ending energy is negative, it's always exothermic. Correct. Correct. That means its energy's gone down. So if its energy's gone down, like if your bank balance goes into the negative, what does that mean? Does that mean you've been spending more than you've been putting in, or putting in more than you've been spending? Spending more, right? So that's why negative is always exothermic. Because you know like when you burn a fuel, energy goes to the surroundings, doesn't it? So that means all the energy is depleted. So the sort of like the product left over has no energy. Zainab, what are you referring to? If a reaction, oh, that says profile. That says profile. Reaction profile. ILE. Guys, let me know once you're ready, yeah? %, Orbison. 100%. Sorry, where has it gone? Oh, here it is. Okay, great. Bro's so locked in, they don't know where the key is anymore. Right. Okay, so let's have a look here, yeah? We've got iodine monochloride. Iodine monochloride reacts reversibly with chlorine to form iodine trichloride. Well done, Zion. I'm glad. And the forward reaction is exothermic. What color will the mixture turn when heated? Guys, what's the first thing you need to know before you even answer this question? What's the first thing you need to know? You can answer it, by the way, but what's the first thing your brain needs to confirm? Exactly, that's the first thing. So figure that bit out first. Thank you very much. Yes. Well done, Yusma and Krish and Gianna. You're all looking at the right thing. Yeah, exactly. Exactly. Well done. Well done, Ajwa. Fantastic. So the first thing you're trying to figure out is what? You're trying to figure out which side is exothermic and which is endothermic. So you're going to draw two arrows, one going like this and one going like this. So the arrow on top, what should I label it? When heated, it is. Okay, I've seen your answer. Just hold up. Hold up, Zion. So what am I writing on the top? What am I writing on the top? Hold on. It says blah, 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 to form iodine trichloride. There's the tri. The forward is exo. So anyone want to change the answer? So the top arrow should be. Thank you very much. Awesome. Thank you, guys. Well done. I'm having a look at the answers, obviously. And then what am I going to label the bottom one? Correct. Very good. Okay. It then says, okay, what color will the mixture turn when heated? Now, do you guys remember the acronym? In N, increase goes N. So the opposite is true as well, right? Decrease is exo. Okay. I'm telling you, man, in the exam, you're going to remember my annoying voice. It's going to be embedded in your head. And you're going to remember my acronyms. Right. So, what we do, we're increasing the temperature. So, therefore, it's going to the endothermic side. So, where's it going? Left or right? Where's it going? Left or right? What are we going to get more of? Left or right? We're going to get more left. Exactly. So, it's going to go more dark brown. Well done for those who got dark brown. We're going to move on. That was not too bad, right? That was not too bad. If I wanted more trichloride, what should I do with the temperature? If I wanted more trichloride, what should I do with the temperature? Oh, the colors are here. Look, can you see the colors? They've told us the colors. So if I know that the reaction is going to the left side, then I just write down whatever color that is. Yeah, well done, Krish. Well done, Yusma. Well done, Mohammed S. Let me know if you heard that. Certainly, let me know if you heard that. I might have said that too quite fast. Lower the temperature. Yes. So the question I asked was, imagine I wanted more trichloride. If I wanted more trichloride, I will decrease the temperature. If I decrease the temperature, the equilibrium will shift into the right side, which is the exo side. Okay. I am talking, yeah. Why have I gone quiet? Hello, hello. Hold up, guys, 1 second. Let's get that open. Yeah, that's me, that's me. Which bit is he on? Which bit? Guys, do you remember when we were talking about rate of reaction and we were talking about pressure? Do you guys remember a particular stipulation? Do you remember a particular stipulation? A particular caveat? Anyone remember? Pressure. Yes, very good. You know, like for example, if I wanted to increase the rate of reaction. You can hear me now? Awesome. Yeah, well done, Manuel. So if I wanted to increase the rate of reaction using pressure, can you guys explain the science behind this? Why does the rate of reaction increase when I increase pressure? Well done, Krish, man. That should be put on your quote list. Why does increasing pressure increase the rate of reactions? Because it forces the reactants together, exactly. And you get you get more successful collisions, right? Agreed? Is everyone on the same page? Okay. So if I had a block of, I don't know, calcium. Oh my days, the Avengers assemble. Right, so we've got calcium there, and then we've got, it's going well, man, it's going well. We've got another substance here, we've got oxygen, right? How are we going to have solid oxygen? That doesn't make sense. Let's say we had calcium chloride, okay? We've got some chlorine. I don't know how we have, so let's call it bromine. Okay, let's call it iodine. Right, okay, so these two things are, yeah, go ahead, Zion, thank you. These two things, that's fine. I appreciate you letting me know. Thank you, Alex. So these two things are reacting. This is a solid block. This is a solid block. Are you guys following? This is a solid block. Will increasing the pressure assist this reaction in any way? Thank you, Zion. Will increasing the pressure increase this reaction in any way? It won't, right? Because they're already in the solid form. They're already close together. Already close. So what are the only types of particles that could benefit from being closer? They're already close. They're already packed. Can you see? They're already packed as a block. Good. The only ones... Thank you for letting me know, Sukmani. So you could increase pressure by closing in the container. Closing in the container. So you could do that. But these are already close to each other. They're already like packed. Right? They're already packed close. Like a hydraulic press. Definitely. Okay. So the only particles I can put closer together are gas particles. Okay. The only particles I can put close together are gas particles. So pressure is only relevant for what? So pressure is only relevant for what? You're probably right there, Mohammed S. It's only relevant to gases. Okay? Only relevant to gases. So, I'll ask you guys a question real quick. When I'm looking at changing temperature, what's the first thing I need to figure out? When I'm looking at temperature, what's the first thing I need to figure out? So, temp. Very good. The first thing that should be on my mind. The first thing that should be on my mind. Thank you, Mohammed S. Well done, Gianna. Well done, Krish. Exactly. Anyone else? What is the first thing that needs to be on my mind? Guys, take a guess. Take a guess. Thank you, Ajwa. It's good revision, people. It's good revision. Good. The first thing you need to figure out whether it's exo or endo, right? You need to figure out whether it's exo or endo. And for pressure, what's the first thing you need to figure out? What is the first thing you need to figure out? Yo, I went one step ahead, man. Yeah. Thank you, Yasma. Ali, not quite. Zia, not quite. We're thinking of pressure. When you're thinking of pressure, what's the first thing you need to figure out? Thank you very much. Thank you, Manya. Kind of, Sukmani, but before that, no worries, George. Thank you for letting me know. Awesome. Guys, you need to figure out if it's a gas or not. Yeah, if it's not a gas, there's no conversation about pressure. Yeah? Not really, because you can't get them closer together. They're already compacted. Do you get it? They're already compacted. We can predict the effect of changes in pressure on a system in equilibrium. Changes in the pressure only affect gases, only gases. In gaseous reactions, an increase in pressure will favor the reaction that produces least number of molecules. So increase affects least molecules. Yeah, sure. Do you know what? I was actually doing a recap of the last one, but I'll go through it. Can I recap it with an example? So increase is for the it shifts the equilibrium to the least side of the molecules. Okay, and a decrease, right? Decrease is the opposite. It goes to the side with more molecules. Correct. That's the one, yes, well. Yeah, pretty much, Mohammed S. Will they tell us the gas? I'm going to tell you now, somebody. I'm going to show you an example. I'll show you now. Well, I don't really have an acronym, but you can remember it as the opposites, right? The increase goes to the least, the decrease goes to the more. So it's just like completely the opposite. Is that okay? Now, if there are the same number of particles or the same number of moles of gases on either side, there is no effect. Okay, so if the gases are same on each side, there's no effect. Increasing the pressure will increase the rate of the forward reaction and backward reaction equally, which is why the position of equilibrium is unchanged. Okay, so if you have the same number of gas particles on the left and the same number of gas particles on the right, it's not going to have any difference because they will just be constantly like negating the change that each one is pushing. So let me show you. Yeah, are you guys ready? Yeah, let me show you. I'm going to show you a reaction. You're joking, right? I think you're trolling, bro. You're trolling. Right, let's look at this real life example. First things first, is pressure even relevant here? And how do I know? Is pressure even relevant here? And how do I know? Thank you, Shauna. Thank you, Mohammed S. Thank you, Trish. Great work, guys. Quick on the answers. Thank you, Manuel. Yes, correct, Manuel. Thank you, Ajwal. Thank you, Yasma. Exactly, guys. Is it relevant? Is it the same? Sorry, is gas even relevant here? So let's just say gas. Is gas relevant here? Is pressure relevant here? The answer is yes. The reason it's relevant, the reason why pressure will have an effect, is because they're both in the gas form. Okay, they're both in the gas form, right? They're both gas. Now, what does moles mean? Moles is one of those words, yeah, which doesn't get defined very well. In this context, I want you to think of moles as molecules. Molecules of gas. So, guys, can you tell me on the board, what have I drawn here? What have I drawn? What have I drawn here? It looks like a bond, you're right, but like all together, what is it? Thank you, Krish. Anyone else? It looks like a bond. Very good. It's a molecule of hydrogen. How many hydrogen atoms in 4 molecules of hydrogen? How many hydrogen atoms in 4 molecules of hydrogen? Very good, very good. Remember, each one has 2. Thank you, George. Thank you, Ajwa. Thank you, Mohammed S. Thank you, other people as well. Very good. So if I had H, that's 1 molecule. If I had H, that's another molecule. H, that's another molecule. H, that's another molecule. How many molecules do I have? I have 4 molecules, and there are 8 hydrogens altogether. How would I write this in a chemical equation? This is what it would look like. Can you see that, guys? That's how I would write it in a chemical equation. Okay? Are you guys following this? Okay, awesome. So, what does that mean? Nice. It's technologia, man. Come on. Right, so here we have 4 molecules or 4 moles of hydrogen. 4 molecules of hydrogen. Are you guys following, yeah? In this context, just think of it as molecule. In calculations, Jana, I want you to think of ratio. We'll cross that bridge when we do calculations again. Okay, so in this context, I want you to think of moles as a molecule of hydrogen. Okay, is that making sense? 4 moles of hydrogen, 4 molecules of hydrogen. Awesome. Okay, right. So Where have I got more molecules? On the left side or the right side? In this reaction here, where have I got more molecules? On the left side or the right side? I'm looking for the chat to see what everyone says. Where have I got more molecules, left or right? I didn't say more atoms. I said more molecules. Molecules. Look at what I've written on the board. It's not. It's not. It's tempting to say it's equal, but it's not. That's right, man. Yeah, correct. So therefore, what would the color be? Right, guys. This side, I have 2 moles of gas. This side, I have 1 mole of gas. Is that okay? Like in algebra, if I write x, that means 1x. If I write 2x, that means I've got 2 x's. Yeah, truly locked in. Truly. Absolutely. Bro's on the comeback season. Is this making sense? Please let me know if this is making sense. If you are confused about anything, now's the time. Because there are 6 together. You're thinking of atoms. You're thinking of atoms. Look. Here are 2 atoms. Here are another 2 atoms. But we don't look at it like that. We look at it like this. This is a molecule of hydrogen. 1 molecule. 1 molecule of H2. 1 molecule of hydrogen. Is that making sense? So how many molecules of hydrogen do I have here? I have 1, 2, 3, and 4. So here I have 2 molecules of nitrogen dioxide. Is that making sense? No, don't worry about the small numbers. Small numbers are irrelevant here. Okay? We're only fussed about the big numbers, which is the number of molecules. Okay? So does everyone understand why 2 is on the left and 1 is on the right? Fantastic. Okay, so we know that an increase in pressure shifts to the less molecule side. Less molecules. And then by opposite, by definition, a decrease in pressure sends it to the higher molecule side, or more molecules. So what are they doing in the question? They're increasing the pressure, right? They're increasing the pressure, right? So therefore, is it going to be more colorless or is it going to be more dark brown? Is it going to be colorless or is it going to be more dark brown? Flood the chat, people. Flood the chat. Test your understanding. Is it going to be more brown or more colorless? More dark brown or more colorless? If we increase the pressure, it goes to the side where there are less molecules. Not less atoms, less molecules. And the numbers in circle, they're the ones that represent molecules. Krish, what's your answer, man? Put it in the chat. Okay, so answer is going to be colorless. It's going to go to the colorless side. It's going to go to the side where there's less molecules. 1 is less than 2, right? Okay. Are we good? Are we good? Comprende, people? I think we agree. Okay. Now, this is one of those moments, yeah, where I really want to look at a question from a test paper which looks at this concept. So just bear with me a second. Let me just load one up. I should not be long. Nah. That's during the break. Right. Where are we? Note, those are notes. We don't want that. Question paper. Okay, right. Have I found the right one? Maybe not. Does everyone know what I'm doing, yeah? Just bear with me 1 second. I'm just looking for a question. I don't want anyone to say, oh, sorry, where have you gone? Gone quiet. Yo, right. Okay then, okay. So you've opened up an exam paper and life has got real quick. The situation has become very serious. Okay, there we go. Thank you for that, Ardion. Right, here we have some information. The stress is piling on. It's the last question of the exam paper. You see that somewhat comforting, somewhat bittersweet message at the end of the exam paper, which says end of questions. So it's the last question on the paper. Right, sorry, I'm doing too much narration here. Okay, it says the equation shows one stage in the manufacture of sulfuric acid from sulfuric dioxide. The reaction is exothermic in the forward direction. Use Le Chatelier's principle to predict the effect of increasing the pressure on the amount of sulfur trioxide produced at equilibrium. So, before you get into all of the sort of difficult parts, maybe there's some things you should try to figure out first. What do you think you should try and figure out first? I mean, the question's asking about pressure. So what do you want to ensure before you even sort of move forward with it? That's true. And is it, Shonav? Is it? Interesting. 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 So remember, this is about pressure. This is about pressure. So first things first, I want to ask the chat, is this information even relevant? Is this information even relevant? This is about pressure. Very good. So is this information relevant? This is about pressure. Guys, this information is irrelevant. It's irrelevant. Okay. Right. So pressure is only important for what? Begins with a G. Begins with a G. It's only relevant for gases. Thank you very much. Are these reactants and products even gases? They are, absolutely. So, I know it's relevant. I gotta sort of persist through now. Okay, so what else should I figure out before I even look at the question? What else should I figure out before I even look at the question? I should figure out... Yes, well done, Krish. Anyone else? Well done, man, yeah. Fantastic. Great answers. And a great answer, Krish. Great answer. Fantastic, Sukmini. I should figure out... Who thinks I should figure out how many gas particles there are? Who thinks I should figure out how many gas particles there are? Is that a fair thing to do? So I'm going to split the left and the right. I'm going to split the left and the right. In the chat, how many gas particles present here? How many gas particles present here? Remember, it's only left versus right. It's only left versus right. How many gas particles present on the right side? On the right side. You're telling me atoms. I'm not fussed about atoms. I want to know how many moles, how many molecules do I have. Fantastic. Well done. Because the majority of the chat is got it correct, I'm going to say a collective well done. There are 2 moles of gas. Okay, let's go to the other side. Let's try and redeem yourself. Yeah, so we're only looking at this number here. And remember, apply algebra to stuff like this. That means 1x, right? Okay. How many molecules of gas on the left? Collectively. How many molecules? Yo, thank you, Josh. The redemption was real. The redemption arc. Right, on the left. How many gas particles altogether? Thank you, George. Thank you, Mohammed S. Thank you, Gianna. Thank you, Sukmini. Thank you, Orbison. This is great. Well done. We're on a roll here, people. We're on a roll. Let's go. Every single person. Zia, drop an answer in. Did I not say it? I feel bad now. I feel bad. It's like when someone says, actually, no, that's a that's a funny example. Thank you, Krish. Thank you. Yes, correct. So this is one gas molecule, and this is another gas molecule. So who thinks I've got 3 here? 3 moles of gas. Very good. You don't think it, you know it. Right, you know it. Fantastic. Okay, now we can look at the question. Le Chatelier's principle to predict the effect of increasing. So does increasing, what do you remember? Increase leads to what? What side? Increase leads to the what side? Chat, come on. The increase leads to what side? Very good. Fewer or least. Fewer or least molecules. So which side has the least molecules? Well done for those who said the right side. So what's going to happen? What's going to happen? You're going to get an increase in sulfur trioxide. In sulfur trioxide, is that what it's called? Sulfur trioxide. Okay. Sorry, Yusma. Guys, if my voice is low, let me know. So you're going to get an increase in sulfur trioxide. Okay. Because the equilibrium will shift to the right. Why will it shift to the right? Because Le Chatelier's principle suggests or states that it will favor the side with fewer molecules if there is an increase in pressure. Right, okay. Can we look at one more question? Can we look at one more question? This is from the same exam paper. Same exam paper, people. Look what they're doing to us, just giving away free marks. They're just giving away free marks at this point. I'll tell you 1 second. So guys, can you answer this question? It was actually a part A, part B question. Remember, they don't really give you irrelevant information. They always give you relevant information. This year was, let's find out. Why can't I find it? 2018. All right, let's go, guys. So use Le Chatelier's principle to predict the effect of increasing the temperature on the amount of sulfur trioxide produced at equilibrium. So guys, after March, we would have finished physics, yeah? So that means from literally April, May, and all the way till mid-June, we'll be doing tons of these, tons of questions. How do you actually answer these? What notes should I write about pressure? Oh, I'll go back. Just hold up a second. So first things first. Oh, the thing about pressure you should have written was this. Where is it? I'll put it on the board like during the break. Yeah, is that okay? I'll tell you what to write down. 1 second, Josh. Well, let's go through it. So first things first, what do we need to figure out? What's the first thing we need to figure out before we even look at the question? Because we know it's about temperature. So if it's about temperature, there's one thing we got to figure out first. Thanks for that, Krish. So the first thing I need to figure out if it's endo or exo. Thank you, Gianna, and thank you, Yusma. So is this endo or exo? Well, it's both of them, isn't it? In the forward direction, it's what? Hold on, man. Hold on. I'm going to read it. It's exo. And what is it there for in the backward direction? It is endo. Very good. All right. Okay. Now we know that we know that increasing temperature goes to what side? In N. And therefore, by definition, the opposite is true. Decreasing goes to exo. Right, I think we have everything we need now to get those 2 marks. Okay, so use Le Chatelier's principle to predict the effect of increasing the temperature on the amount of trioxide. So, if we increase the temperature, is it going to go to the endothermic side? So, is the endothermic left or right? Is the endothermic left or right? Endothermic is left. But where's trioxide? Endothermic is left, but where's trioxide? Trioxide's on the right. So is that going to go up or down? Is trioxide going to go up or down? Thank you, Gianna. Thank you, Mohammed S. Thank you, Ali. Well done. So the endothermic side's on the left, but trioxide's on the right. So we know increasing is going to favor the endothermic side. So that means trioxide on the exothermic side is going to go down. For those who wrote a long answer, let me know if that's what you said. Less is produced, goes down. Yep. Or you can just say equilibrium shifts to the left. Basically, everything I wrote here, just put it in words. Put it in words. Okay, guys, we're going to move on, yeah? No, remember I told you, those are atoms. Those are, you're thinking of pressure. This is not a pressure question. This is temperature question. So it has nothing to do with atoms. There's nothing to do with the moles. It has everything to do with which side is exothermic and which side is endothermic. Let me know if that makes sense. Guys, whilst I load up what I need to load up, who can remember what this answer is? Who can remember what this answer is? So less reactant is formed. Less reactant is formed. Let's see what you wrote. Yes, you can say that, but you need to say where the equilibrium favors. So the equilibrium favors the left. So that's the only thing you need to mention. George, you're thinking of the right thing. Just the application is slightly inaccurate, but you are thinking the right thing. So that I know you're like on the right sort of thought. Actually, no, I think you're right. No. Sorry, Josh. George, I think you're right. %, yes, ma'am. That's it. Well done, Adion. So, guys, sulfur dioxide is a simple molecule. Okay, it's a simple molecule, and therefore it has weak intermolecular forces. Or you can say it's a gas, and therefore has weak intermolecular forces. And you know what the last thing is that a lot of people forgot to say? Therefore, less energy required to overcome weak forces of attraction. This is a paper 1 question, by the way. Yes, that's correct. So many. At this stage, yes, that is the answer. So sulfur dioxide is a simple molecule, which is a gas that has weak intermolecular forces, therefore less energy required to overcome weak forces of attraction. Anyway, guys, so we'll do more questions when that time comes. We're going to get back to where we're supposed to be, which is crude oil. We're going on to the next topic now. We're going to the next topic. Not a long one, actually. So let me just get this on the board. Guys, we'll take a quick break, yeah. Hold up, 1 second, 1 second. Uno minutos. I know it's long for triple, 100%. Oh, sorry if I just made someone host. Okay, thank you for that, Sokmini. Guys, we're going to take a quick 5-minute break. If there are any notes you need me to go back to, can you let me know? So I think it was I need to go back to pressure, was it? I'm not watching it at the moment. I want to, but it's not possible. No, not that, man. The answer for the effect of increasing. Okay. Did that actually? I'll check out the highlights. Right. Okay. Where are we? Was it this one? The answer for the one saying this affects the effects of increasing. So, do you want to go to the question or do you want to go to the notes? And then George, you wanted the pressure one, right? So the pressure one is just this one. Increased pressure will favor the least number of moles. Thank you, Jana. The greatest number of moles. Okay, like how we write an answer. Okay, hold up. I'm gonna go back to it. Let me just, George, let me know when you're done with this bit. I'll go back. Guys, I'm gonna put a timer on. We're gonna have a break. The timer is on. Okay, guys, so let's continue. Let me know if you're back. Sure enough, if you hang back until the end of the lesson, I'll answer your question. Yeah, that's a good question. Just remind me at the end, and I'll talk about it. But have an Espa, that just doesn't sound right, does it? Okay, organic chemistry, organic. So a quick overview, just a quick overview. Thank you guys for letting me know, by the way. So a quick overview. So organic chemistry is a chemistry of carbon compounds. So literally, carbon is that special. It has its own own branch of chemistry. Carbon forms a vast number of compounds because it can form strong covalent bonds, which we'll see a lot of. You don't need to write this down, by the way, with itself. This enables it to form long chains of carbon atoms, and hence an almost infinite variety of carbon compounds are known. Carbon always forms 4 covalent bonds. This is very important to remember, which can be single, it can be double, it can be triple. A functional group is a specific atom or group of atoms which confer certain physical and chemical properties. Okay? Organic molecules are classified by the dominant functional group. So we'll talk about some functional groups. There'll be some that we pick up today. Organic compounds organic compounds with the same functional group, but a different number of carbon atoms are said to belong to the same homologous series. So same functional group, but different number of carbon atoms. Every time a carbon atom is added to a chain, 2 hydrogens also join it. Okay, so let's talk about this in a bit more detail. There was nothing really to write there. I was just sort of introducing the idea. So let's have a look. Okay. So types of formula. General formula. This type of formula tells you the composition of any member of a whole homologous series. For example, all of the alkanes have the general formula CnH2n. Okay, we've all heard of that before, right? CnH2n plus 2. So this will essentially tell me if something falls into the homologous series alkane. This tells you however many carbon atoms there are in the alkane, doubling the number and adding 2 will give you the number of hydrogens. So let's say, for example, I had C100. What would be the remainder of this thing? I think so, Ali. I think so. Exactly. So H will be 2N. So 2 times 100 plus 2, 202. So that's still an alkane, even though it's got large chains. Displayed formula. This tells us, this shows us the spatial arrangement, okay, of all atoms and bonds in a molecule. And then you have, this is the molecular formula. This shows the actual number of an atom, okay, in a molecule, one molecule at a time. So this would be the displayed formula, how they are displayed, okay, the spatial arrangement. And this thing here is the molecular formula. You need to know what they're talking about, because if they say to you, write down the displayed formula of methane, and you go ahead and do this, you will get that wrong, even though that is methane. If they want the displayed formula, they want you to do this. Let me know in the chat if that makes sense. So this is the molecular formula. If you didn't know, now's the time to write it. Molecular formula. And this is the displayed formula. How do I know this is an alkane? How do I know this is an alkane? Good, it follows the general formula. If I double 4, I get 8, and if I add 2 to it, I get 10. So that's how I know it's an alkane. Right. Have we all got one example of that written down? Just in case they ask us what displayed is, what structural is. Sorry, displayed is, what molecular is. Okay. Let's do another one. So now we're looking at structural formula. This gives information about information to make it clear, to make the structure clear, sorry, but most of the actual covalent bonds are omitted. Only important bonds are shown, such as double bonds or triple bonds. Okay. So if you look here, can you see the double bond? And here is, you know that's an alkane because there's no double bonds, right? And here you have another double bond. So just remember what the structural formula is. So this here is the displayed formula. And this here is the structural formula. Let me know in the chat if that's okay. By the way, if you're a bit confused on how that turns into it, let me show you. So do you guys see this thing here? In that yellow box, how many carbons are there? There's 1 carbon. How many hydrogens are there in the yellow box? Good. So would you say that that is basically CH3? Would you say that yellow box is CH3? It is, right? So that yellow box is that. That yellow box is that. Okay. This purple box is CH2, and it's right there. Guys, can you see it? So the way that the chain is per carbon. Per carbon. You can remember it as a structural formula is per carbon. Okay, and it also represents, so you can write structural per carbon plus double or single bond type. Will the small number always go by the H? It has to, because that's the number of hydrogens. Are we good? Okay, so I'm going to draw MEPB. So I'm going to draw butane. M, E, P, and B. MEPB, methane, ethane, propane, butane. So that's that, and then you got and then we shall have okay, so now what I'm going to do, I'm going to write down, this is structure A, this is B, and this is C. Can everyone in the chat tell me which one is the structural formula? Which one is the structural formula? Is it A, B, or C? Structural formula. I'm actually so glad I asked this question. So we're already mixing them up. So which one is the structural formula? Structural. Okay. So the structural formula is this one here. Okay. I know it's a bit confusing, But there you go. Okay. Is that okay? Does everyone understand that? Yeah. Is everyone alright with that? Which one is the displayed formula? Which one is the displayed? Displayed shows the spatial arrangement. The spatial arrangement. Alright, Hassan and Krish, man. Chill, chill, chill. So the answer is A. This is the displayed. The last one is called, begins with an M. Thank you, Krish. Thank you, Hassan. Thank you, Yasma. Thank you, Mohammed S. Thank you, Zia. This is good, guys. Well done. It's called a something formula. We call it the, yeah, thank you, George and Hassan again, apparently. Right, this is called the molecular formula. Guys, can you take a moment to note these three down, please? I need you to know the difference. And just in case you don't believe me, structural, where did I put it? Ah, there we go, structural. So structural, and we know that's the displayed. So can you just get these three written down if you got it wrong? I'll give you a moment to write that down. What's the structural formula for CH4? So it would actually just be CH4 because there's no groups. It's just like on its own. So we can't really separate the carbons. There's only one carbon. So molecular formula for CH4 and structural formula for CH4 will be the only ones where they're the same thing. Let me know if that makes sense. Yeah, I'm here. Right, okay, we good. We got that down, yeah? Let's move on. Okay, so let's talk about the homologous series. So the first homologous series we're going to talk about are alkanes. Okay, so what is a homologous series? So things we can say about a homologous series. So each member has the same functional group. So methane, ethane, propane, butane, they're all the same. Okay, they just have extra carbons. Each member has the same general formula. Okay, general formula being CnH2n plus 2. So they always follow the same formula. And each member has similar chemical properties. Each subsequent family member differs by CH2. Members have gradually changing physical properties. For example, melting point, boiling point, and density. So let's have a look. So what is one observation you can make about the melting point as you increase the chain size? What's one observation you can make about the melting point when you change the chain size? So as you increase the chain size, what happens to the temperature of the melting point? Is there even a trend? Is there even a trend? Not really, right? It starts to get lower and lower. And then at butane, it gets really high. You get it? So here is gradually getting lower and lower. And then boom, butane is just so high. Okay? So not really a trend there. There's not really a trend there. Maybe when we start looking at longer chain molecules, there'll be a big chain. How about boiling point? How about boiling point? So we're going from liquid to gas. How about boiling point? As you increase the chain number, is there a trend? Very good. Yup. So as you increase chain number, boiling point also increases. Okay, and you can see that there. Bit of a trend. So which one is most likely to be... Actually, no, it all says gas. Okay, so a few facts to go through. So the composition of crude oil, and let me just get a sort of a drawing to go with it. Okay. Right, let's have a look. Okay, so crude oil is a finite resource. What does that mean? Finite resource. So crude oil is a finite resource. Yes, it means it can run out. It means that it's limited. Okay, that means there's a fixed amount. Crazy, that's crazy, Hassan. So there's a fixed amount. And limited. Okay, crude oil is a complex mixture of lots of different hydrocarbon compounds. Okay, so there's lots of different sizes. You can have larger compounds, you can have smaller compounds, but they're all hydrocarbons. Is that making sense? So crude oil, would you call crude oil a raw material? Would you call crude oil a raw material? 100% you would call it a raw material. Okay, it's something extracted from the ground. So if it's extracted from the ground, what does it need for us in order to use it? It needs some level of processing. Would you agree? Yes, fantastic. Thank you for that, guys. So you need some level of processing, and then we can start using it. So we can't use it as it is. So crude oil is a complex mixture of different hydrocarbon compounds of different sizes. Hydrocarbons are compounds that contain hydrogen and carbons only. If you didn't know that, write that down. It is thick, sticky. It is a thick, sticky black liquid that is found in porous rock. Okay, porous rock under the ground and under the sea. Crude oil is formed. Sorry, let me move this a bit. Crude oil is formed over millions of years from the effects of high pressure and temperatures on the remains of biomass, mainly plankton that was buried in mud. Guys, this is the sentence you need to get written down. Let me know once you've got it down. Where we can separate. Yes, that's right, man. Yeah, correct. Correct. So we know it's formed over millions of years. So is it renewable? Yes, after millions of years. But that's not realistic because we won't be like even alive for a fraction of that. Okay, so crude oil is formed over millions of years from the effects of high pressure and temperature on the remains of biomass, so plants and animals, mainly plankton that was buried in mud. It is being used up much faster than it is being formed, which is why we call it a finite resource. Okay, are we good? And then we'll finish off with this part here, just a couple of examples. Okay, alkanes. Alkanes are a group of saturated hydrocarbons. The term saturated means that they only have a single carbon-carbon bond. There are no double bonds. So what's a double bonded hydrocarbon going to be called? A double bonded hydrocarbon, at least with one double bond anyway. It leads up to this, just more. Sorry, I read the wrong name. Hassan, so it leads up to it. Good, it will be unsaturated. Okay, unsaturated. Okay, the general formula for alkanes is CnH2n plus 2. They are colorless compounds which have a gradual change in their physical properties as the number of carbons in the chain increases. Alkanes are generally unreactive compounds, but they do undergo combustion. Combustion means it needs to be heated in the presence of what? It needs to be heated in the presence of what? Exactly. Well, we've done this many a time, but it wasn't no harm in saying it again. So it needs to be heated in the presence of oxygen. That's what it means to combust something. It can be cracked into smaller molecules and can react with halogens in the presence of light. Okay, methane is an alkane and is the major component of natural gas. So natural gas is methane. So methane is super flammable, right? Okay, can everyone in the chat tell me how many carbons in propane? How many carbons in propane? Well done, guys. So just remember MEPB, MEPB, MEPB. Oh, yeah. That's a sick one. Monkeys eat peanut butter. That's a good one. Monkeys eat peanut butter. That's a good one. MEPB. So I asked you guys about propane. So use that acronym to help you. That is so random. Okay, guys, let me put it on the board. No, it's not me. I had someone else put it in the chat. I think it's quite a good one, actually, to be fair. Okay, so MEPB. Now, why do I say you only need to know MEPB for now? The only reason you need to know MEPB for now is because after butane, it just follows the... After butane, what does it just follow? What the polygons, right? So after that, it's pentagon, pentane. I know. Come on, guys. Right, pentane, and then you got the next one, hexagon, hexane, heptagon, heptane. Okay. Right, octagon, octane, and the list goes on. Right, so MEPB. Yo, that's a bit crazy, Krish. Right, so let me know in the chat if that's okay. So you just got to remember the first four. MEPB. Yeah, dodecane. Or decane. Yeah, M, E, P, and B. Okay. Guys, you have a week ahead of you. A week ahead of you. Please don't waste it. Do the 9-hour days, people. Do the 9-hour days. You will not regret it. Treat this week like it's the week before your exam. I'm promising you it's going to be work wonders. It's very easy to get locked in with some I don't know, some Rocket League and some Netflix and some other garbage. Wait, what do we classify these as? Basically, they're, look, methane, ethane, propane, butane, MEPB. MEPB. You have Mock's first day back. Fair enough. So, guys, really try your best to lock in. Really try your best to lock in. Just a reminder, guys. Yeah. There's a song with this. Go and find it. It's quite funny. Yes. What was I going to say? Oh yeah. So yeah, try to revise. That's the first thing. Second thing, whoever does triple science tomorrow is the triple session. It was supposed to be today. I mean, it was supposed to be at some point, but I've put it temporarily for tomorrow. So tomorrow is the triple lesson. From Thursday, our lessons will end at 8, just for about 4 weeks. Okay. So from Thursday, our lessons will end at 8, just for about 4 weeks. Okay. Also, another thing. Oh yeah, that's it. That's it. So the triple lesson will be tomorrow at 10 a.m. 10 a.m. I have alerted all the parents about it. Guys, if there are any concerns you have, this is a good week to tell me so I can schedule some extra time to go through it. Because my biggest concern is I can't schedule time because it will be too late or it'll be too early. Okay, but this is the half term. So did you guys hear what I just said? So if there's something you genuinely don't know and you're worried about and you're thinking, why don't I know this at this point? Please tell me and I can set up a session to go through it. So maybe it's electrolysis, maybe it's the Le Chatelier's principle, maybe it's, I don't know, balancing equations, whatever it is, calculations, whatever it is, even physics and biology, let me know and I can try and set up some time. And I'll also let everyone know so they can all sort of join in. Guys, a magnetism. Okay, I'm about to go through it, by the way, as in like, I'll probably be the first topic I go through for physics. For tomorrow triple, can we get, that's what we're going on to? Yeah, that's what we're going on to. Guys, balance equations. Okay. Fleming's left-hand rule. Is it because you have a mock coming up? Is that why you want to go through it? Or are you happy to wait till I go through it in the physics lesson? Because I can, a lot of people have, 2 people have said magnetism, so I can set it up. If your mock is immediately, as soon as school starts, then of course I can go through it now. But if it's something you can wait for when we go through physics, because I'm going to go through it, I can do it then. So you let me know the level of sort of imminent, like how imminent you want me to go through it, and I can do that. So let me take a picture though, by the way. Everyone said that, right? So let me take a screenshot, I mean, of what everyone just said. Okay, I think I might do it. Balancing and chemical equations as well. Okay. If anyone is asking about balancing and chemical equations, I'll set that up too. So I'll try and set up 2. Okay, guys, I've got that noted down. Please communicate, yeah? Please communicate. I'm here to help you guys. I will try my best wherever I can. Okay, I will do Mohammed. Guys, enjoy your evening. For those who have triple science, tomorrow at 10 a.m. I'll see you then. For those who are doing the extra math lesson, guys, sorry, not extra math lesson. For those who are doing the grade 9 lesson for maths, please remember Saturday 6 p.m. Okay, take care, people. See you around. It was, right? Thank you, Mania. Thank you, Kivi. Thank you, Ali. Thank you, Adian, Yasma. Take care, people. Thank you, Krish. Thank you, George. Can you send the 10 a.m. reminder for tomorrow? As in, like, early morning? I can do that. Sure, now, let's answer that question. Great question. Let me just stop this recording.